Victor Tango, Victor India Romeo, Mumbai ground.
Read you to Victor Tango, Victor India Romeo.
Victor Tango, Victor India Romeo, Mumbai ground. How do you now?
Read you for Victor Tango, Victor India Romeo.
Can you do a readability check?
How to do that, sir?
Take my call sign, your call sign, and then ask how do you
Okay, so your call sign will be?
Mumbai ground or Mumbai control, whatever.
Yeah. So I'll say Mumbai ground, then my call sign, and then I'll say, how do you read?
Hmm.
Yes. So Mumbai ground, Victor Tango, Victor India Romeo, how do you read?
Victor Tango, Victor India Romeo, Mumbai ground. Radio 5. How do you read?
I read you for Victor Tango, Victor India Romeo.
You don't have to say I. You can say radio.
Okay. Read you for. Okay.
So where do you stand on the homework?
So I did not do all, but I did not do the last table actually. I did rest of it, but not the last one. Yes.
Sorry, there were 3 flight plans.
One second, I'll check.
There was a
Yes,
lot
sir.
of
There
3
were.
flight plans, and then there were solutions for heading and what? Ground speed.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. I did two flight plans, and I did the for heading and ground speed. I did solutions for that.
How much is pending?
But sir,
How much is pending?
right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 to 14 questions.
When are you planning to finish?
I'll do it now after the class. And I'll send you.
Okay. What is track made good?
But sir,
What is track made good?
track mid good is the angle between is the angle between the required heading and the true heading and my true heading, which is caused due
Oh,
to
no,
drift,
no.
I guess.
Tracks. Heading is the direction in which the nose of the aircraft points.
Nose
Why
of the
don't
aircraft is
why don't
pointed.
you go through your notes? Have you not written the definition?
Required track. Yes, sir, yes, I have written that.
So
Required
don't
uh,
answer before
track.
thinking. Think before answering.
Yes, sir. Okay, this is track mid good. Yes.
Check. What is the definition?
Yes, sir. So track made good. Yes. Yes, sir. Track made good. I didn't wrote the definition, but I wrote what is track made good here. Okay.
What is track made good?
So, like, should I explain in my words?
What have you written?
I have not written the definition, sir.
Do you not remember what it
I
is?
I remember what it is.
If you don't
So
remember,
track made good is a no. So I remember that, but I remember it in my language. So I'll just tell. So according to me, track made good is the is the is a track made by aircraft when it is drifted away from its required track
So the
All
difference
required
between the angular difference between the required track and the actual track. That
actual track. Yes, sir. That is track movement good.
so why are you comparing it with heading? You should not compare it with heading. And
Yes, sir. You told
I
me that
think I
earlier.
have shared two documents, Google documents with you
Yes, sir.
guys.
Yes, sir. Yes, sir. Yes, sir. You have.
There we have certain definitions. I'm checking right.
So, oh, directions. This. Mm.
So there is a document by the name Directions.
Directions. Yes.
Uh, Let me see if we have mentioned heading there. Fine. We will come to track made good definitions, but it's good you remember. But
Yes, sir.
you related it with heading, required heading and actual heading.
Heading. Yes, sir. Yes, sir.
I'm
Yes,
not
sir.
sure if that's
It
the correct
is.
answer. That is not the correct answer.
Yes, sir. It is. It will be on the track. Yes. Track movement good.
We did discuss one definition, the angular distance of
The
track.
angular distance between, yes, 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 of track required and the actual track we're flying on.
Is it mentioned somewhere?
No, so I don't see it actually. It is not. So track made good TMG.
Track made good is the track which is not good actually because it is taking us away from our required
Away
track.
from our required heading. Yes,
We
sorry,
change
our
the
required track.
heading. We change the heading by applying the wind correction angle or closing angle or total correction
Yes,
angle. Do you remember?
total correction angle. Yes, I remember that.
So that we can stay on the required track.
Yes, sir.
So your required track basically is your planned track. Okay.
Yes, yes.
So your actual track is basically your track made good
Track made good. Yes.
because you have drifted away from.
Drifted away from due to winds. Yes.
Yes. So today we are going to discuss about the 1 in 60 rule, uh, which
Yes,
is
sir.
uh, related to your track made good and something that we have already discussed. So today we'll see how to
Yes.
actually find the corrections. So uh, the philosophy behind the track made good is pretty simple. I hope you can see the screen.
Yes, sir, I can.
So say that you had to one,
Yes, sir.
let's start. Okay. So I'm drawing a line for 60 centimeters. Okay, this
Yes.
line is 60 centimeters.
60 centimeters.
Say this is the required track or the
So can
planned
I
track.
explain? So can I try to explain this?
Uh,
I'll just try.
no, it's okay. We are going to discuss
Okay.
uh, the 1 by 60 rule. So you
Okay. Okay. Yeah.
focus,
Sure.
focus, and
Yes.
afterwards you can try and explain. So say
Yes,
this
sir.
is your starting point, departure point, A. Okay. Reaching B, if you realize that your aircraft is on the left of your required track by 10 centimeters. Now, what is my
Okay.
direction of flight? This is my direction of flight.
Yes.
From A to B, when I reach B, if I realize that I am 10 centimeters left of my required track, 10 centimeters,
Yes, sir.
then what did I actually fly on? I flew on this track, which was the track made good.
Track made good.
Okay. So what is your
Yes.
track error angle? TEA. Track error angle is this angle.
Yes, sir.
Zulu. We'll name it Zulu.
Zulu. Yeah.
1 by 60 rule tells us, okay,
Yes, sir.
1 by 60 rule tells us that if after traveling 60 units, if you find yourself at 10 units right or left, then the angle Zulu will equal to 10 degrees.
Okay.
This is 1 by 60 rule. Are you following? So
Yes, sir.
now you know that your track error angle was 10 degrees. So being here on a new position, Charlie, you will you will be going like this if you don't make the correction.
Correction.
So track error angle 10-degree correction if you make in the opposite side, then you will find yourself flying straight
Straight.
like this.
Ye-
But you
Yes.
don't have to go straight. You have to reach the planned track
Plan track.
destination, and which was somewhere here, delta.
Yes.
Say the distance left is again 60 centimeters.
60 centimeters.
If it is 60 centimeters, then you will be required to fly on this track to reach delta. Now, because this is 60, this is 60, correction, this is 60, this is 10, this angle is 10, and if this angle is 10, this angle will also be 10.
Then
So your total
correct.
correction angle is equal to 10 degrees plus
10
10
degrees
degrees.
plus
This
10 degrees.
this 10 degree is track error angle, and this 10 degrees is closing angle.
Closing angle.
Okay.
Yes,
So
sir.
total correction angle is equal to 20 degrees. So when you reach Charlie, you have to change your heading by 20 degrees to reach your destination.
Okay.
When you are on Charlie, you have to change your present heading by 20 degrees to reach your destination. You're only making
Destination.
changes in your heading because that's the thing you can control.
Heading.
So this green is track made good. And this is required track or planned track.
Required track.
RT. A to B is distance traveled AB is distance flown and BD is distance to go.
Yes, sir.
Now, a pilot will not always realize that he's off track at 60 nautical miles or 600 nautical miles. The figure will change. It could be 45 nautical miles, it could be 20, it could be 100, it could be 180. So we cannot simply assume that we'll always get 10° or 15°. There has to be some sort of
Okay.
formula which will help us find it.
Yes.
Okay. Just let me give you another example. Say
Yes,
if
sir.
traveling from A to B, somewhere, say if this was 120 nautical miles, at 60 nautical miles, I realize that I am 8 nautical miles left of the required track.
Left of the required track.
8 nautical miles. So what is your
Yes.
track error angle? Track error angle is
Track angle is 8 nautical miles.
angle. We're talking about angle.
Track error angle will be 840, 8 nautical miles. Acha, track error angle. So it will be 8 nautical miles only, no? I think. One second.
Can angle be in nautical miles?
No, 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 no. This will be 8 degrees.
8 degrees,
Oh,
yes.
okay. If it is, yes,
Why?
8
Because
degrees,
you're
yes.
8
Angle.
degrees, 8 nautical miles left. This 1
Yes,
by
sir.
60 rule stays true up to 20 nautical miles and 20.
20 nautical miles.
So
Yes.
if you realize, say
Okay. So, like, so,
another
yeah,
example,
for
if you find yourself at 20 nautical miles
20
and if
nautical
you have
miles.
traveled
Yes.
60,
Yes.
so this angle will be 20 degrees. This is
20 degrees.
max.
Yes.
Max.
Okay.
Above this value, your 1 by 60 rule does not
Will not be
give you
apply.
answers.
Mm.
Does not apply.
Yes. Okay. Okay.
Are you following what we are doing? You don't have to go back
Yes,
to
sir.
old
Yes, sir. I
pages.
am.
We are starting fresh.
Yes, sir.
So we call this line as adjacent line because this is adjacent to your angle, and we call this as opposite. This is basically a right angle triangle,
Right angle triangle.
and
Yes.
the whole trigonometry is applied to give us 1 by 60. But we don't need to get into that. We just need to understand that if I've traveled 60 to realize I'm up to 20 off track, either right or left, then my track error angle will be equal to the distance. That is the opposite
Equal to the distance. Yes.
distance off.
Yes, sir.
Okay.
Okay. And so in this, the distance flown can be vary. Like any distance
Yeah, in reality, it will
I
not
can be. Like
always
if
be
I have flown
60.
45 nautical miles.
It can be 45, it can be
Yes, sir.
50. So whenever that is the case, we have to apply a formula. So that is something that we will see right now.
Okay.
This is
Yes.
known as measuring angles in flight. So basically, you're measuring your track error angle. Which angle? Track error angle. So the difference between the
Track
required
error
track
angle.
and the track made good will give you track error angle.
Track error angle.
Difference between the required track and the track made
Required
good.
track and try. Yes, yes, yes. Track made good.
Write down all keywords. 1 by 60 rule is applicable up to 20 degrees.
Yes, I'm writing.
Yeah, write down these words so that you don't forget it. And the same rule is used when we are calculating a glide slope and approach and landing related sums.
Okay. Mm, track made good plus.
So let's just simply jump onto the formula. Okay. What is Z? Z is the track error
Yes.
angle.
Track error angle.
Zulu Z. So Z is equal to distance off. Distance off is how many nautical miles you're off track, right or left. Okay.
Off track.
Distance off.
Yes.
Divide by distance gone. This is the distance you have traveled so far.
Traveled. Yes.
Hmm. Multiply by 60.
Multiply by 60. Okay. So like I have flown 60 nautical miles and I am 30 nautical miles away. Okay. From my yes.
I'll give you an example. You find
Yes.
yourself 6 miles right of track after 40 miles along track. What is the value of Z?
So Z will be sir
What is the
this
distance
is
off
6 miles.
value?
No. 6 miles.
6. Good. Miles means nautical miles here. Okay, don't confuse.
Yes.
And
So
what's
sir
your
it
distance gone?
40.
40.
So
Multiply
can we not
by.
directly say that it will be 6 degrees?
Why 6 degrees? You
Because
have
you
you have
told me
flown,
that
but you have flown 40 nautical miles. The rule stands true for 60 nautical miles.
60 nautical. Okay, okay, okay. Yeah, yeah. Okay, okay, okay.
I told you when the answer is not 60, we have to use a formula.
Formula, yes. Okay. Okay, 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 okay. So if here is 60, so it will get yes, sir. समझ गया या
So what's the answer?
into 60. Yes. 40 into 60. 9 degrees.
9 degrees, correct. So you got your track error angle. But this is not your closing
Yes.
angle. This is just that you have realized that your required track is different from your track made good. And right
Different.
now you are 9
Track made
degrees
good.
off track. Good. Now you have to find out what's your total correction angle. So one
Yes.
correction you'll apply will be 9 degrees. Okay, you were right. So you will turn 9 degrees to the left, but that will keep you
Left.
parallel on the track. You
Parallel
need
on the
to
path.
close,
Yes.
come close. So how to solve the closing angle? There will be a formula for that also.
Okay.
Similar formula. This is known as returning to track.
Yes, sir.
Write down this definition, this one.
Yes, sir.
Read it out.
The track you intended to fly is called a planned track. The track you actually make over the ground, presumably because the actual one second
Because
actual
the
wind is
actual
different
wind is
from the
different from the
forecast. Yes, sir.
forecast.
Is the track made good? The difference between them is track error angle.
Did you write it down?
Yes, sir.
Now, do you think track error angle is equal to drift?
Track error angle is equal to drift. Yes, sir. I think so. Track.
Wow.
Yes, sir. Yes, sir. It is.
So quickly? Are you so thorough with navigation? You're so quick to give me answers. You're not even pondering about it.
Track error angle is not drift. The common mistake
Read,
among drifting
read
is
this. Read this in the bracket. Presumably, because the actual wind is
because
different from the
different
forecast.
from the forecast.
It is not
Yes, it
talking
is
about
different.
zero wind.
Yes, yes. It
So
is
it
not
is
talking
not
about zero.
drift. You were probably flying a heading which was not as same as planned track.
Not as
So you are already applying
oh,
allowing for a drift. But even after allowing for the drift, you realize that you're off track. That's how
off
you
track.
get track made good. Following?
Yes, yes,
This is
I
a
am.
common mistake which beginners make, but we should not make. Drift is strictly angle between heading and track, while track made good is between planned track and required track,
Plan track
actual
and the
track,
required
actual
actual
track.
track. Yes.
So track error angle is not same as drift because drift is the angular difference between heading and track. The track could either be planned or it could either be TMG. Are you following?
Yes, I am.
Please understand it flawlessly. Take your time. Let
I'll
it
take a
sink in.
screenshot.
Take your time. Let it sink
Yes.
in. This will get you marks. These are sure short answers they will ask you in the examination. After this session, if you give me wrong definitions, then I'll not be happy with it, okay?
Yes, sir.
Understand, take some time to memorize these.
So can you please repeat that why it is not drift? I did not got that.
Read the definition of drift and read the definition of track error angle. You will understand.
So drift is angle between the heading, okay, and my track
And what is track error angle?
and track. Okay, it is between track made good and my planned track. Yes. Hmm.
Write down.
Okay. Yes, sir. Yes.
Your track error angle can add to your actual drift. Okay, I'll show you. Read this. The difference between the planned track and the TMG
And
is the track error angle, correct?
yes, sir.
The difference between the heading and the planned track is is the expected drift.
Expected drift.
The difference between the heading and the track mid good is the actual drift.
Actual drift.
Write it down.
Yes.
So heading and TMG will give you actual drift.
Drift.
Are you following?
Yes, sir, I am.
So let's take this example. Say this was your planned track.
Sir, I cannot see the screen.
Why not? Okay, wait.
Yeah.
Say this is your planned track. 0900. Okay? Planned track. You are required to maintain a heading of 100 to be yourself on the planned track. So your aircraft, it's not 0. Come on. Let's take 10. So your aircraft will be showing this direction. Your aircraft will be pointed in this direction, but it will keep flying 0900.
090. Yes.
So the aircraft heading is 100.
100.
Okay? Are you with me?
Yes.
Let's make a
Yes,
aircraft
I am.
in yellow and let's check. So, wait. So this is your aircraft. And so right now this aircraft has a heading of 0900 and a track of 0900.
090.
Okay?
Yes.
I want to change the heading. Now my aircraft is on a heading of,
100 degrees.
so I'll show you how it actually works. The aircraft flies like this.
Okay.
Got it?
Yes, sir.
To maintain on the track. So its heading is 100, but its track is 0900.
0900.
Are you following? So the direction will
Yes, I
always
am.
be 100, but the aircraft will continue on 0900.
0900.
Following?
Yes, sir.
This is how heading, this is drift. This is allowed drift,
Allowed drift.
expected drift.
Yes.
What is the drift? Is it port drift or starboard drift?
The drift here is like this. Okay. So drift is one second. So drift is port drift.
Very good. Very good.
Yes.
So you have turned starboard to allow for port drift.
Starboard port drift.
Very good. Very good. Very good answer. So you've got it. So the aircraft heading will change, but the aircraft will keep moving like this. So this is how drift
Yes.
affects. This is actual correction, expected drift. So the pilot is
Yes, sir.
told that you please keep a heading of 100 to be on a track of 0900 because of a wind forecast.
Okay, so sir, here the wind is coming from starboard side and it is pushing the aircraft towards port side. So the aircraft is turning towards starboard side.
Yes,
Okay,
yes, very good. To allow further drift so that it is not
to
pushed
allow for the
away.
drift.
Yes, very good.
Yes,
But while making the diagram, we make a diagram with a red arrow like this. But now you
yes,
know that your aircraft is still on the same track. Okay, now that is drift. Now you know what the drift is between aircraft heading and the track.
yes, and the track,
Angular difference between aircraft heading and the track.
and the
Okay,
track. Yes,
but the problem happens when reaching a certain point, you realize that you are left
okay,
of your planned track. Okay, this is your TMG.
yes,
Got it?
yes, sir.
Now, carefully, the difference between the planned track and TMG is your track error angle.
Track error angle.
The
Yes,
difference
and the
between
difference between planned track and my heading is drift. Okay,
this,
yes,
this,
yes, sir.
and this total angle is your actual drift.
Drift.
Actual drift.
Yes, sir.
Got it?
Yes, sir. Yes, sir. I got it.
Is the concept clear? Heading, track mid.
Yes, sir. Yes, sir. Yes, sir.
Easy now?
Yes, sir. It is cleared. Yes, sir. Yes, sir. Very easy now. My plan track.
Understanding is one thing, remembering is another thing. Now,
Another
Viraj,
thing.
you have to
Okay.
understand these are new concepts and your brain will think they are not logical because we have not built those basics. So you have to strongly revise and build these basics in your head so that you can never get confused.
Confused. Yes.
So track error angle, we showed it in green. Heading and plan track is the drift, we show in red.
Right.
Yeah. So good. Now let's get back to formula to find our total closing angle so that we can return to track.
Yes, sir.
Do you have any questions?
No, sir. I have no question as of now. No.
So let's take this example, start sketching it now.
Yes.
Your total track distance is 78 nautical miles.
78 nautical miles.
After traveling 30 nautical miles, you realize you're 4
Yes, sir.
nautical miles left of track.
Okay. 4 nautical miles left of track.
Hmm. So what will you do? The first thing you'll do is find track error angle.
Track error angle.
Quickly find out the track error angle. What is the track error angle?
Yes. So, equals to gone. So the distance gone was 30 nautical miles, no?
Yes.
Okay. 4 by 30 into 60. So 8 nautical miles, 8 degrees, sorry, 8 degrees.
8 degrees to the left. Very good. So if you turn right 8 degrees, you will start paralleling
Parallel.
on
Yes, sir.
parallel to your planned track. But we need to find closing angle also.
Yes, sir.
Then we'll combine the total correction. Eight-degree to right will bring you parallel on track.
Well on track, yes. So are you sharing the screen? I cannot see the screen.
Right. I'm just writing the equation as you're solving. I'm just one
Yes,
step
yes, sir.
behind you. So this is it. So 8 degree to right will bring you parallel to track.
Yes, sir.
You need to find closing angle now. To take you to destination.
Okay.
Got it? Closing angle
Yes.
to destination after correcting for track error angle. Okay.
After correcting. Yes. Yes.
We'll take a breather quickly and we'll start doing these sums. 5
Yes,
minutes.
sir. Yes, sir. Excuse me, sir. Are you there?
Okay. So for closing angle, we'll use the same formula. The
Okay,
only
the
change will
same
be
formula.
distance to go. So for track error angle, distance gone.
Gone. Yes.
For closing angle, distance left to go, distance to go
Okay.
into 60. So
Mm, sorry.
out of 78, 30 nautical miles have already traveled. So how much is distance to go?
Yes. After 42. No, I guess. Yes.
30
42.
minus 78,
40. 30 minus 78 will be 48.
48. How much?
Yes.
What is the distance off track?
4 degrees.
4
4
nautical
miles.
miles
4 nautical miles.
into 60. What is the answer?
48. 4 upon 48 into 60. 5 degrees.
Total correction angle is equal to track error angle plus closing angle is equal to 9. It was not 9, right? It was 8.
It was 8. Yes, it was 8.
8 plus 5 is equal to 13 degrees. So once you reach 4 nautical miles off track, after flowing 30 nautical miles, you realize that you're off track. So you have to take a turn by 13 degrees to your right to
13
reach your
degrees.
destination.
Yes, sir.
Are you following?
Yes, I am. 13 degrees.
So now questions.
Yes, sir.
We'll solve a couple of questions.
I just know one thing. Will apply the 1/60 rule when the distance will be 60 nautical miles, right?
No, 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 no. When the distance off track is less
Off
than
track.
20 nautical miles.
Okay, and the distance flown.
That doesn't matter.
Okay,
It could be anything now.
okay.
We were just taking an example. If distance flown is 60 and if distance off is 10, then the angle
Yes,
is 60, correction, 10. It matches
yes,
the
sir.
opposite side.
Opposite side. Yes, yes,
So, but now you stick to the formula always. Even if you're traveling
yes.
60, you stick to the formula, you'll get the same answer.
Same answer, right?
Because 60 by 60 will get cancelled.
Will be cancelled. Yeah.
Quickly solve this question.
Yes,
It's just to find out your track error angle.
yes, sir.
What's its answer?
So I cannot see the screen.
Ah, sorry. Check now.
You're from A to B, and you are to find at 60 degrees. Okay, position is 16 outbound. Is 7 degrees from to the left. What is my track Angle when position is 60 nautical miles outbound. Okay, 60 nautical miles outbound. So I'm flying from A to B. I find that my position is 60 nautical miles outbound from A and 7 nautical miles to the required track. What is the track correction angle? Okay.
Track error angle.
Track angle, yes. So, 7, 7 degrees.
To the left or right?
Uh, 7 degrees. 1 second. To the right. 7 degrees to the left.
Very good.
Yes. You are flying position
Do the
is
second one.
120 nautical. Yes, sir, 120 nautical miles. Eight, 80 into 60. So 4 degrees to the right. 4 degrees towards it. Right side.
Very good.
Six.
Do the third one.
Yes, sir. 90 into 60. So 4 degrees right.
Very good. Do the fourth one.
8 degrees left.
Are you solving or just guessing?
No, so I am solving in my calci.
Very good. 8 degrees to the left. Very good.
Left.
Do question number 5.
Yes, sir. Mm, if you're flying from J to K, which is required track, but true, your position is what is it? TMG. What is my track made good? Okay. So track made good is the different.
Let's see
Okay,
if you
so
can solve
0.
this.
Yes, sir, yes. So 0, 5 degrees too. All right. Yes, I'll solve. Mm, so 4, 80 into 60 will be 3. And to the left. Okay. So which is required track of 0, 4, 5 like this. 0, 4, 5. And to the left. 3 degrees to the left. Okay. So track made good is basically a difference between my land. Yes. Price plan track actually go. The triangle actually go is made good. What is your track made good? So 1 second, I'll give the answer. I'm solving. So 3 degrees is track angle is 3 degree. Okay. Uh, distance. So tell me, my track error angle will be 3 degrees. Okay, and it is to the left. So what will be my track made good? Mm,
Remember sexagesimal system directions
yes,
clockwise.
sir. Yes, sir. Yes, sir. Yes, sir. So like this. Okay, 3 degrees.
So what will you do with 3 degrees and 0.45?
Okay, so my track made good will be 048.
Are you on the right side of your track or the left side of your track?
I'm on the left side of my track. Sorry.
So simple.
Yes, first track. Yes. So it will be 042.
Mm.
Yes, I'm on the left side of my track. Yes,
Why are you making the same errors
042.
that you were making with drift earlier? Why are you not focusing? What if
No,
the
sir, I
same thing
am.
happens in the exam, even after having
No, sir, it
learned?
will not. I'll read the questions 2, 3 times first, then I'll solve.
Yeah, it's so simple, right? If you
Yes,
avoid making silly mistakes, these are very simple sums. Quickly
yes,
do the
sir.
sixth one.
Yes, sir. 145. 4 degrees. 220 degrees, right? So 223 degrees. 224, sorry, 224 degrees.
Good. Always check your answer 2 times.
Yes, sir, yes, sir. 224. True.
Do seventh.
I'm flying 315 degrees. Okay. To the left. Okay. So say 40 into 60, that is 9. So 3, 306. To the left. So 306. True.
306. True.
Yes.
Do the eighth one.
Yes, sir. Oh, a survivor places himself 660 meters from.
Same formula, just reverse calculations.
Yes, sir. 4 degrees. Mm. So, a survivor places himself 660 meters
Viraj, it's
from a
surveyor.
mast.
A
Okay.
surveyor.
Oh, yeah. Oh, sorry. A surveyor. Yeah. A surveyor. Sorry. So sorry. A surveyor places himself 660 meters from a mast. Okay. And measures an elevation angle of 4 degrees to the top of the mast. Okay. So,
If you can solve this, I'll quickly say you are a genius. Everything is
I'll
given to you. You have to use your common sense, logic,
common
nothing
sense.
else.
Yes.
You
Yes,
might
sir.
not know what a mast is, you might not know what an elevation angle is, I understand, but you know what formula to use.
What formula to use? Yes. So, mm, is it 9,900? Mm, so I'll try once again. One second. So 4 degree. Hmm. Good. It's 4 degrees. Okay. And 600.
Check the screen.
Yes.
Angle is 4 degrees
4 degrees. Yes.
is equal to,
Dash
he has kept himself 600 and how many
600.
meters?
660.
660 meters away from a mast. A mast is a pole.
Port. Okay.
So this is the point.
Okay. Okay. 660. 600.
A
Yes.
surveyor is a person. Okay, check this out.
Yes, sir.
Check the screen.
Yes, I
He is
am.
the surveyor.
Yes.
There is a mast, a pole, a mast.
Yes.
He keeps the mast from him at a distance of 660 meters
Meters.
with an elevation angle, this angle, that
Yes,
is
sir.
4 degrees. He checks out the mast. So he wants to calculate what is the height of the mast. So this is the
Height of the
height.
mast. Yes.
So does it not run in tangent with our 1 by
Tangent.
60 rule?
Yes, sir. Yes, sir. Yes, sir. With a
So
1/60
distance
rule.
of, correction, distance gone. This is distance gone. This is distance off. The height is distance off basically.
Yes.
And this angle, elevation angle, is basically your drag error angle.
Right error angle.
Yes. So now do the formula, do the math. Should I show you how to do this
Six.
math?
Yes, sir. Please. 60 here.
So this is x basically.
X. Yes.
So you keep the x here and take everything on the other side. The
On the other
moment you
side.
take
Yes.
everything on the other side, everything will reverse.
Reverse.
Multiplication will
Yes.
become division, division will become
Division.
multiplication. So
Yes.
this is division. So this will become multiplication here
Multiplication here.
into 4. And this is multiplication. This will become division.
Yes.
So your equation will be x,
Six.
it
Six
is
ones
equal
are
to 4 into
11s are
660 upon
44.
60.
44.
Yes. 44
44.
meters is the height.
I got that once, but I thought that it was
Oh,
not
you
the
got it?
answer.
Then why didn't you try using that as an answer?
See, I did here 44, but I thought that 660 meters mast. Okay, so he was away.
I'll tell you a
Yes.
secret. If your basics are
Yeah.
strong now, then whatever your mind comes up with will be a correct answer. Okay,
Yes, sir.
which just happened, but you were not trusting that answer
Yes, I was not trusting. That is true.
because तुम्हें logic नहीं समझ आया. But फॉर्मूला में सही रिप्लेस किया.
हाँ,
रिमेंबर आई टोल्ड यू ग्लाइड स्लोप से रिलेटेड भी क्वेश्चंस पूछेंगे आपको जहाँ पे सेम
यस
फॉर्मूला
सर
यूज होने
पूछेंगे.
वाला है. एंड यू आर नॉट रीडिंग द क्वेश्चन प्रॉपर्ली. सर्वे को सर्वाइवर बना दिया.
सॉरी सर.
So, दिमाग में सर्वाइवर से रिलेटेड सब कुछ आ जाएगा.
यस सर, ट्रू. आया था
देन विल
या.
बी लाइक ये सब क्या आ रहा है नेविगेशन में, ये तो मैंने पढ़ा ही नहीं है. फिर दिमाग में आंसर आएगा भी, फिर गलत हो जाएगा. ऐसा होगा.
हाँ.
What is the answer? 44 meters.
44 meters. Yeah.
Let's see if you can do the ninth one.
Hmm. You're flying an instrument approach to an airfield. It is 3 degrees. Okay. That should be exactly 2 nautical miles. to- From the touchdown point. Okay. $6,000 feet. 2 nautical miles. 200.
What's the answer?
I think 600
What's the unit?
feet.
Very good. Perfect answer. Easy now? Now you can
Yes,
solve
sir.
glide slope questions also. Question number 10.
Yes, sir. You are
Quickly,
correctly
quickly.
on the glide, so we are passing a height of 1,000 feet. Okay. Mm, 90, and it is 2.5 degrees. Okay. So can you show me the question once again?
Wait.
Yes, this one, yeah, 10th one. You are correctly on a counter glide slope and you're passing 1,000 feet. QFE, okay.
Solvable?
Okay. Yes, I'm trying. 1,000 feet. What is your range from 1,000? So 60 or 5. Okay. So 4 nautical miles?
Perfect.
Yes.
Solve the 11th one.
Yes, sir. You're flying from Q to R, which is required track. 125 position is 240 into 60. That is 3 left. And what track must you fly arrive at? So what track must you fly to arrive? Oh, okay. Yes, that is right. Yes. So to the left, the yes or no? 225. So that will be 122 true. 122 degrees true. So 1 second, I'll just connect my charger. It is 5% now. One second.
Mhm. You are not reading the question properly. You're making silly mistake. Are you sure with your answer?
So 125 true. Okay. And to the left. So 125 to my left. I'll just do it again.
What track must you fly to arrive overhead R? So it is your new track basically. They are not asking about what is your present track. They're asking about what
Present track.
track will you
Okay.
fly
What track must you fly?
to arrive over R.
Okay. So 120. So I should fly 128.
You following
I
how?
got. Yes, sir, I am.
Last question, question number 12.
Yes. That is 6. And that is to the right. Okay. That is to the right मतलब इधर है कहीं तो भी तो 556 okay 272 so 266.
Perfect. Good job. You have any questions so far?
No sir, I don't have questions. No.
What's the formula?
Formula is z is equals to distance of upon distance to go into 60.
Distance to go, distance gone.
No. Distance gone. Sorry. Distance to go is for total correction
Closing,
angle.
closing
Distance to
angle.
go.
That is for closing.
Closing angle. Yes. Yes.
What's the formula for closing angle?
Distance of upon distance to go into 60.
Revise everything that we have done today.
Yes, sir.
We'll solve a few more sums when it comes to total correction angle. There are many methods to do these calculations, but this is what we will use, and this is the most easiest. Uh, End of your syllabus, I will share textbooks with you, which you'll read. Once you read those textbooks, they will discuss more strategies to solve similar sums. It's up to you to gain
Okay.
that knowledge. But right now, we don't want to expand much because you're just a beginner right now. So we need to stick with
Yes.
what works the best for us. Slowly, when you get very thorough with these concepts, automatically you will realize that there are certain techniques which you could directly apply looking at the question to get an answer. But
Yes.
now is not the time to go for shortcuts. So we are discussing all possible methods. We'll stick to what is the best option for us to solve.
Yes, sir.
Question number one.
Yes, sir.
Read it out.
If an aircraft is 3 degrees off required track at range of 120 nautical miles, how far in nautical miles required track is? Okay. Mm, so 3 degrees away. Okay, 3 degrees. Okay. And 30 millimeters, 6 degrees. Okay. Distance of to go. How far in nautical miles is the aircraft of? Okay, I have to tell that in nautical miles. Okay. Hmm. 3 degrees here and 20 here. Okay. So ones
Pretty
are
simple, right? If
2.
you look at the question, you
Yes, sir.
understand how you can
6.
make that triangle.
6 nautical miles.
Very good. Very good. See, if you observe, if you take time to understand, it comes to you.
Yes, sir.
Do
If
the
an
second one.
aircraft is 2 miles of track error. Okay. Track error and 40. Sorry. 240. 3 degrees.
Mhm. Very good. Solve the third one.
Uh, an aircraft leaves A to B, 95 nautical mile distance. 95 nautical mile distance left 135. The question is find from pinpoint. So, nautical miles at the right. Okay. Nice. So can you just scroll up to question number 3? Yes. I'm so sorry for 70 is right. So 735, 60. So My tracker is 12 degrees. What alteration of heading is required
You
to
did not
fly
tell
direct?
whether it's right or left.
Yes, sir.
You did not say whether your track error angle is to the right or left.
Right. 8 degrees right.
8 or 12? You just said
12, 12,
12.
12, 12, 12. Yeah, 12 degrees right. What is the alteration of heading if required to fly directly at B? Okay, so 12. So 83 degrees.
What? You have to go to your destination B.
Okay. Yes.
You are uh, reducing 12 from 95. That is nautical miles. This is degrees. What? That is distance.
Yes. Yes. I thought that is heading. Sorry. Mm,
What alteration of heading? Basically, what is your total correction angle? Come on.
okay, TCA.
प्रेजेंट हेडिंग को क्या करेक्ट करोगे डायरेक्ट डेस्टिनेशन पे पहुंचोगे आप
Yes, sir. So this is 12 degrees and TCA will be distance of 12 by distance to go. 60, so 12, 60 into 60, 12. That is 24.
sorry
24.
wrong
So you
what is the formula for closing angle
distance off upon distance to go into 60.
so how much is your distance to go
Distance to go is 95, 60.
60 right so what's your closing angle
Yes. So my closing angle will be 12 divided by 60. So it will
why
be 12, no?
why are you doing 12 divided by 60 how what is 12 where what should come in place of 12 distance off track right what's the formula
Yes.
what are you using in the formula
Distance off upon distance to go into 60.
so what is distance off
Okay.
no what is distance off
Distance off is 7
yeah now use the formula what is distance to go
into 60. 7. 7 degrees. So 7 degrees plus 12 degrees, that will be 19.
and which direction will you apply the correction to your heading you'll change
Correction
your
I'll
heading
apply
by 19
towards
degrees correct
left.
yes
Left.
do you think you can take me in the exam to solve sums for you do you
No,
think
sir.
I'll be there to assist you
No, sir.
so make sure that you don't make such errors in the examination
Yes.
you're not you're silly mistakes these are silly mistakes that you're making why were you
Drift is
taking
starboard.
why were you first saying अरे 12 ही होगा आपने फोकस ही नहीं किया डिस्टेंस टू गो एंड डिस्टेंस ऑफ में कितना डिफरेंस है
Yes, sir.
12 ले लिया 7 के जगह पे इट्स कॉल्ड ब्लाइंडिंग इट हैपेंस इनिशियली कीप योर फोकस शार्प व्हाट इज द ड्रिफ्ट
Starboard.
व्हाट इज द वैल्यू ऑफ ड्रिफ्ट
Okay, value of drift. 19 degrees starboard. No,
रियली
sorry.
रियली
Sorry. No. No, sir, sorry. So I'm so confused. Hmm.
व्हाट इज द डेफिनेशन फॉर ड्रिफ्ट
Yes, sir.
डेफिनेशन फॉर ड्रिफ्ट
Drift is angle between my required track and my head and my current track.
That is drift.
Yes, sir, that is drift. I think so.
We just checked, right? We just did it.
Yes, sir.
See the screen?
So the difference between heading
You're not
and the
writing it.
planned track, I guess. So I'm writing that track
So,
is not
so why you're giving me a definition for track error angle when I'm talking about drift?
okay. Triangle is not planned track and track. Okay. Planned track.
Please master these definitions, yeah. Why you confused? What's the definition for drift?
The difference between the heading and the planned track.
Do you have heading in the question?
No, sir.
So you cannot calculate drift.
Yes, sir. I cannot calculate drift.
Simple. You should be confident.
Yes.
कुछ भी बोल रहे हो आप 19 degrees बोल रहे हो total correction angle that is the actual drift we are only talking about drift and that is also not
Drift.
definitely actual
Yes.
drift because we don't have the heading
Yes.
बिना
Heading.
heading के आप drift calculate नहीं कर सकते हो
नहीं कर सकते.
so I think your mind is saturated we'll stop here the next two sums are a homework for you
Yes, I'll just take a screenshot.
wait let me write it down यार ड्रिफ्ट का कैसे आप मेरे को गलत बता रहे हो डेफिनेशन अभी तो हमने सॉल्व किया
Yes, sir. अभी हमने solve किया. सही बात है. Shit, man.
एग्जाम में 100 क्वेश्चंस होंगे कैसे मैनेज करोगे ये सब के आंसर्स मुझे आज रात को चाहिए ये दोनों क्वेश्चंस के
Yes, sir.
और कल का होमवर्क कभी सबमिट कर रहे आंसर्स भी तो चेक करने हैं
सर
उसके
अभी 1 hour में एक घंटे में आंसर में.
प्रायोरिटी पे ये रखो
Yes, sir.
ये आज रात से पहले पूछते
Yes, sir.
हैं लेट मी राइट प्रॉपर्ली सो दैट कैन टेक okay question number 4
Yes,
and
sir.
5 on the same page
Yes, sir.
did you take a screenshot
Yes, I did.
so take your time study again and again to master these topics the formula is simple but it's confusing
Yes, sir.
master the
Confusing.
definitions you want to take a screenshot of this page this part
So I cannot see the screen.
yeah I'll share it here.
Yeah.
This part
Yes, sir. I'll just take.
Hmm. Study it thoroughly tomorrow if you give me wrong answers then it will not be
Yes, yes. I'll not give wrong answers tomorrow.
good you have done a good job today just a little bit of confusions which should not happen if you think the confusions are persistent then you tell me I'll explain you again so that we can get rid of the confusion but don't
Yes, sir.
compromise
Yeah.
okay so submit me these two questions by end of night tonight and
Yes, yes. I'll do.
finish that also the homework to you
Yes, sir.
tomorrow we'll do something to do with the shape of the earth great circle distance and everything that again
Yeah.
is like if you don't focus then it is very confusing but everything is
Yes,
0
sir.
to 360 the whole general navigation is based upon clockwise directions right left that's it it's pretty simple if you focus on these points So today we learned
Yes, sir.
about the difference between drift, track error angle, what is the definition of track made good, and we saw with our example what happens because of wind. When the wind is different from the weather forecast, that's when you will get track made good. When the wind is as same as forecast,
Track
your
made good.
heading will be different from your planned track so that you can allow for the drift.
Plan track.
Something that
Drift.
I hope you are following.
Yes, I am following.
See if you have any questions.
Yes. So can you just explain that again? When when the wind forecast is different, that
See, there is slightly a time when there is zero wind.
okay.
Okay. Now you are required to maintain a track so that you can maintain a airway to reach a distance.
Yes.
Depending
Yes.
upon your wind, you will be told that you have to maintain a heading, constant heading, which will keep you on track so that
On
you
my
can
track, yeah.
allow for the drift. So your track and heading will
Allow
be different.
different.
So as a good pilot, you will focus on maintaining that heading and automatically you'll find yourself on the track.
Yes.
Now, if the wind changes from what you were ready to allow for the drift, then you'll realize that maintaining the same
Okay.
heading, you will be on a
I'm
new
getting
track.
okay.
That
Yes.
new track
Okay.
is track made good, your actual track.
Track made good. Yes. Okay.
Now that you realize you are off your actual track, off your required track, then you do these corrections to your heading
Heading. Yes.
that will compensate for the new wind, basically.
New wind. Yes.
And you will
Okay.
automatically, after doing the corrections, reach your destination.
Yes, sir. Okay.
Following? Are you following?
Yes, sir.
So one
Yes, sir.
thing you
Yes,
have
sir.
to understand is that drift is something which you have allowed for
Allowed for
depending upon your weather forecast. And drift is
weather
difference
forecast.
between heading and planned track.
Heading and plan track. Yes.
The moment the wind changes when compared to your forecast, you will get a track made good, which is the difference between your planned track and your actual track.
Actual track.
It means on your
Yes.
actual track, that is TMG, your heading will still be the same, which you were keeping
Yes, sir.
earlier. Only your track is changing now.
Actual track is changing. Yeah.
So now you will find the angular corrections and apply that to your heading so that you can reach your destination. What do you need?
Reach
You need to know the distance off, the distance gone, and the distance to go.
to go. Yes.
Your track error angle and your closing angle. Five things required to get yourself back on track.
Yes,
Try
sir.
to imagine you're flying and these things are happening to you when you're flying.
Yes, sir.
See if you have more questions. Read, revise, study, or else it will be very
Yes, sir.
difficult.
Yes, sir. No, sir, I don't have any questions as of now. I'll just read everything again. I'll revise everything again. Yeah.
Yes, thoroughly. Do it thoroughly.
Yes, sir.
Okay, then I'll see you tomorrow.
Yes, sir.
Okay, take care then.
Bye bye. Thank you so much.